Derivatives, your gateway to understanding change. Welcome to the fascinating world of derivatives. Derivatives are fundamental to calculus, unlocking secrets about how things change. They're like mathematical detectives, revealing the hidden patterns in the way quantities vary. Whether it's the speed of a rocket, the growth of an investment, or the spread of a disease, derivatives help us understand and predict these changes. Let's embark on this journey to demystify derivatives, equipping you with the knowledge to tackle real-world problems with confidence. Get ready to see the world in a whole new light. What exactly are derivatives? Imagine driving along a highway. Your speedometer doesn't show your position, but rather how your position changes over time, your speed. That's essentially what a derivative does. It tells us the rate of change of a function. Think of a curve on a graph. The derivative at any point on that curve represents the slope of the line that just grazes the curve at that specific point. This line, known as the tangent line, tells us how steep the curve is at that exact location, giving us a sense of how quickly the function is changing. Let's say you're analyzing the growth of a plant over time. The derivative of the growth function would reveal how fast the plant is growing at any given moment. Pretty cool, right? Demystifying the derivative, a mathematical perspective. Mathematically, the derivative of a function f(x) at a point x is denoted as f prime of x or df dx. It represents the instantaneous rate of change of f(x) with respect to x. The formal definition of the derivative involves limits, which can seem a bit intimidating at first. But don't worry, we'll break it down. This formula essentially calculates the slope of the line connecting 2 points on the curve of fx. As those points get infinitesimally closer, this limiting process gives us the slope of the tangent line at the point x, which is the derivative. Mastering the rules, your derivative toolkit. Just like a carpenter has a toolbox full of essential tools, calculus provides us with a set of powerful rules to find derivatives effortlessly. These rules act as shortcuts, allowing us to calculate derivatives without having to go through the formal definition every time. Some fundamental rules include the power rule, the constant rule, the sum and difference rules, the product and quotient rules, and the chain rule. Each rule addresses a specific type of function, providing a streamlined approach to finding its derivative. By understanding and applying these rules, you'll be well equipped to tackle a wide range of derivative problems with ease and accuracy. The power rule is your secret weapon for handling functions with exponents. It states, this means that to find the derivative of x raised to any power n, you simply multiply the term by n and reduce the exponent by 1. It's that simple. For example, let's find the derivative of f of x equals x cubed. Applying the power rule, we get c. The power rule makes finding derivatives a breeze. Conquering constants and sums in the realm of derivatives. The constant rule and the sum and difference rules are your allies in simplifying derivative calculations. The constant rule states that the derivative of a constant is always 0. This makes sense because constants don't change, so their rate of change is always 0. The sum and difference rules tell us that we can differentiate sums and differences of functions term by term. This means you can break down complex functions into smaller, manageable parts and differentiate them individually. These rules may seem simple, but they are incredibly powerful tools that you'll use constantly when working with derivatives. Derivatives in action, real-world applications. Derivatives aren't confined to textbooks, they're everywhere. In physics, derivatives help us describe velocity and acceleration. In economics, they analyze marginal cost and revenue, optimizing production and pricing strategies. In medicine, derivatives model tumor growth and the spread of diseases, aiding in diagnosis and treatment planning. They even play a role in computer animation, creating smooth and realistic movements. The applications of derivatives are vast and diverse, demonstrating their significance in understanding and solving real-world problems across various disciplines. Embrace the challenge. Practice makes perfect. Mastering derivatives, like any skill, requires practice. The more you work with derivatives, the more comfortable you'll become with the concepts and rules. Start with simple examples and gradually increase the complexity. Don't be afraid to make mistakes, they are valuable learning opportunities. Seek out resources like textbooks, online tutorials, and practice problems to solidify your understanding. Remember, the journey to mastering derivatives is a marathon, not a sprint. With dedication and consistent effort, you'll unlock a deeper understanding of calculus and its applications. Derivatives, unlocking a world of understanding. Congratulations on embarking on this exciting journey into the world of derivatives. You've gained a foundational understanding of what derivatives are, how they are defined mathematically, and the key rules for finding them. Remember, derivatives are powerful tools that allow us to analyze change in a multitude of contexts. By mastering these concepts, you're opening doors to a wider understanding of mathematics, science, engineering, and countless other fields. Keep exploring, keep practicing, and embrace the power of derivatives to unlock a world of knowledge.